Think about the digital ground you're standing on right now. Underneath every screen is an operating system, passing data through a browser and routing requests across thousands of miles of physical infrastructure. For decades, the security protecting these systems has operated on a reactive model. We wait for a component to break before we attempt to fix it. When a hacker identifies a weak point and writes a script to exploit it, security teams must scramble to reverse engineer the attack and distribute a patch to every user. This creates a perpetual cycle of reaction. Every patch requires human engineers to manually spot the problem and test the solution, a process that often leaves the vulnerability open for weeks. The global network effectively rests on thousands of hidden fault lines, passively waiting for an attacker to strike the right spot. Finding these fault lines before an attacker does requires digging through millions of lines of aging legacy code, a process known as digital archaeology. Some of these flaws have been buried for decades. Researchers recently unearthed a bug capable of crashing a remote server in OpenBSD that had been sitting in the codebase for 27 years. A similar flaw was found in FFmpeg, the open-source software handling video processing for major platforms. That bug had been hiding for 16 years. This chart puts that history into perspective. On the left is the 16-year lifespan of the FFmpeg bug. On the right, the counter shows that automated testing systems hit that specific code 5 million times without ever flagging the error. Human researchers cannot scale their efforts fast enough to manually review every repository that automated tests routinely miss. Relying on manual detection leaves the internet exposed to zero-day exploits, attacks that strike before a defense even exists. Anthropic developed a model called Claude Mythos Preview, equipped with a capability called agentic coding. Mythos operates entirely autonomously, constantly hunting for hidden vulnerabilities across vast software ecosystems without waiting for human instruction. The CyberGym benchmark shows the scale of this jump. The previous model solved 66.6% of these challenges, while Mythos Preview reached 83.1%. Performance increases across other engineering evaluations as well. SWE-Bench Pro climbed to 77.8%, and Terminal Bench 2.0 reached 82%. These benchmarks confirm the model's transition into autonomous cyber operations, where it executes the full lifecycle of complex security tasks independently. High-severity exploits rarely stem from a single glaring error in a wall of code. Sophisticated attacks rely on chaining, the process of taking 3 to 5 independent minor bugs and linking them together to create a critical pathway into a system. Mythos simulates an attacker's logic, identifying these minor flaws and autonomously figuring out how to link them. During a review of the Linux kernel, the model developed a local privilege escalation exploit, successfully chaining low-level bugs to move from user access to root control. A human security researcher might spend a full day of work discovering and linking those specific flaws. Mythos performs the same work in minutes. To build a sufficient defense, the developers first had to produce a tireless offensive weapon. Because of its profound proficiency in autonomously chaining exploits, the model functions effectively as a fully automated cyber weapon. This success created a dilemma. Anthropic cannot release Mythos Preview widely because of the severe risk of misuse. In the hands of an adversary, the modding could find and exploit 0 days exponentially faster than defenders could ever patch them. The technological breakthrough designed to save the internet possesses the exact mechanics required to dismantle it. Anthropic is now pivoting to a defensive first strike strategy called Project Glasswing. They have formed a coalition of 10 launch partners, including Apple, Microsoft, NVIDIA, and the Linux Foundation, to unite across the tech industry. The initiative includes $100 million in model credits for these partners and $4 million in donations to support open-source maintainers. The objective is to give defenders a collective head start, using the AI to scan and patch critical vulnerabilities before an adversary can weaponize them. This coalition establishes a state of preemptive immunity, finally securing the digital foundations that modern society relies on.